Among the three main components of wood, paper industry mainly exploits the cellulose fraction, which implicates the removal and loss of lignin and hemicellulose polymers in the mill side stream. However, these fractions constitute interesting renewable sources of aromatic compounds and sugars that could be valorized into new bio-based products in the so-called wood biorefineries. WoodZymes project, funded by the Bio-Based Industries Joint Undertaking, has been devoted to contribute to the full exploitation of wood biomass through the collaborative work of 11 partners from 4 European countries. The project goal was to develop tailor-made enzymes able to work under the extreme operation conditions of pH and temperature demanded by the wood processing industries such as kraft pulping and board manufacture. The new extremophilic enzymes and extremozyme-based processes aim to provide high-value bioequivalents of petroleum-derived chemicals for selected applications. Here, we're going to tell you about the most promising results obtained during the project. By 2 different approaches, screening of databases and protein engineering, WoodZymes partners found and developed a set of new thermotolerant and alkalophilic enzymes, chylinases acting on hemicelluloses and lactases acting on kraft lignin. The best performing extremozymes reach high pilot and industrial scale production using enzyme technology platform. Kraft lignins isolated from the black liquors of the pulp mills involved in the project were enzymatically refined using metning technology. Sets of softwood and hardwood lignin-derived fractions with decreasing molecular weights were produced and chemically characterized prior to the application tests. The lignin fractions were evaluated as components of polyurethane insulation foams with up to 50% substitution of oil-based polyols. All the lignin samples were compliant with foaming requirements, although some process adaptations are required depending on the lignin properties. The new extremophilic lactases were also tested in the manufacture of medium-density fiberboards. The application of the enzymes had a positive effect on energy savings during defibering of wood chips. WoodZymes lignins were also tested as a phenol substituent in the formulation of lignin-phenol formaldehyde resol resins that were extensively characterized during the project. The use of lignin fractions enabled to obtain suitable resin formulations with a substantial decrease of the phenol and formaldehyde contents, being this effect more pronounced in the presence of lactase. In the case of kraft pulp bleaching, the use of the new extremozymes allowed reducing the chlorine dioxide charge and, consequently, the load of organochlorinated compounds in the bleaching effluent. In particular, integration of the most extremophilic chylinases in the bleaching sequence of eucalyptus pulp enabled saving up to 25% chlorine dioxide at pilot scale without affecting pulp mechanical properties. Finally, highly pure hemicelluloses were extracted from bleached kraft pulps with the aid of extremozymes. These sugars were chemically modified and evaluated as additives in papermaking. Cationized hemicelluloses allowed significant energy savings during paper refining and notably improved the mechanical and physical properties of paper sheets. Moreover, the paper can be recycled, preserving the enhanced properties. To sum up, WoodZymes project facilitates a new interconnection between the pulp and paper industry, enzyme technology providers, and fiberboard and insulation product manufacturers. These will result in increased competitiveness of European kraft pulp biorefineries, facilitating the industrial exploitation of all components of the biomass feedstock in several applications. We have shown that the adoption of clean and environmentally sound technologies based on extremozymes leads to energy and chemical savings in the wood conversion sector. Moreover, substitution of fossil-derived chemicals by bio-based components reduce the carbon footprint of WoodZymes products, as shown by life cycle assessment.